Welcome to Brain Vision.
It is observed that 55.5 ml of water at 20 degrees Celsius completely fills a container to the brim. When the container and the water are heated to 60 degrees Celsius, 0.35 grams of water is lost. What is the coefficient of volume expansion of the container, and what is the most likely material of the container? Density of water at 60 degrees Celsius is 0.98324 grams per milliliter. So our initial equation that we're going to start from is delta V, so change in volume, is equal to a coefficient of volume expansion times a change in temperature multiplied by the initial volume. If we look at if we just heat 55.5 milliliters of water at 20 degrees to 60 degrees, our change of volume will be given by delta V, let's call this delta V water for clarity, is equal to coefficient of volume expansion, which is given in the table, or look it up, 210. So in this case, B is 210 times 10 to the minus 6. So 210 times 10 to the minus 6. And the change temperature 60 minus 20 is equal to 40. The initial volume is 55.5, so times 55.5. And from that, if we plug that in, we get 0.466. So is equal to 0.466 milliliters. So the volume of water lost is simply going to be given by 0.35 divided by the density, which gives us the water lost is equal to 0.35 divided by the density, which is 0.98, blah, 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 0.983, which is going to give us 0.360 milliliters. So we can see from that the change of volume of the container is simply going to be given by the change of volume of water, subtract the volume of water lost. So that is simply 0.466 minus 0.360. So delta V container is equal to 0.106 milliliters. So now, rearranging this, because we've got to find a volume of coefficient expansion here. So beta is equal to delta V divided by V delta T. And we now know all of this for the container. So delta V is simply given by 0.106 here. V is given by 55.5. And delta T is given by 40. So plugging all of that in here and popping that on a calculator, we get that it is equal to, B is equal to 4.8 times 10 to the minus 5. And the closest one on the table is copper at 5 times 10 to the minus 5. So the material is copper. So that's part A, and part B, copper equals 5 times 10 to the minus 5. 5 times 10 to the minus 5, and this should have a units degrees C minus 1. Yeah, copper B. So the beta value, degrees C to the -1. And that's your answer.